Synchronous optical networking and synchronous digital hierarchy are standardized protocols utilized to transfer multiple digital bit streams synchronously over optical fiber, employing laser technology or highly coherent light from light-emitting diodes. These protocols were developed to replace the plesiochronous digital hierarchy (PDH) system for effectively transporting large amounts of telephone calls and data traffic over the same fiber without synchronization constraints. SONET and SDH were initially crafted to support real-time, uncompressed circuit-switched voice encoded in PCM format. The crux of the issue prior to SONET SDH was the varied synchronization sources of multiple circuits, leading them to operate at slightly different rates. SONET SDH revolutionized this by enabling the concurrent transport of numerous circuits of diverse origins within a unified framing protocol. Both SDH and SONET are prevalent today, with SONET prominent in the United States and Canada, while SDH dominates elsewhere globally. SDH sets itself apart from plesiochronous digital hierarchy, PDH, by implementing tightly synchronized rates for data transportation across the entire network using atomic clocks. This synchronization capability allows extensive inter-country networks to function synchronously, minimizing the need for excessive buffering between network elements. By encapsulating earlier digital transmission standards or supporting asynchronous transfer mode, ATM, or packet over SONET SDH POS networking, both SDH and SONET act as versatile transport containers for carrying voice and data. The inherent flexibility of SONET SDH signals facilitates the transmission of various services within its virtual container due to its adaptable bandwidth features. SONET and SDH, though sometimes described using distinct terms for identical functions, with few exceptions, can be viewed as SDH being a superset of SONET. SONET functions as a set of transport containers allowing the delivery of diverse protocols like traditional telephony, ATM, Ethernet, and TCP/IP traffic, making it a multiplexed structure promoting low latency for encapsulated data. In SDH, the fundamental unit of framing, the STM1, Synchronous Transport Module, Level 1, operates at 155.520 megabits per second. On the other hand, SONET refers to this fundamental unit as an STS-3C, Synchronous Transport Signal 3, concatenated. An STS-3C comprises 3 multiplexed STS-1 signals, which may be transmitted over an OC3 signal. The basic transmission unit in SONET is the STS-1 or OC1, functioning at 51.84 megabits per second, a speed dictated by the bandwidth requirements of PCM-encoded telephonic voice signals. The framing in synchronous optical networking involves interleaving the overhead with the payload during transmission. Each frame, such as the STS-1 frame, consists of a specific number of octets transmitting the overhead, followed by the payload, thereby enabling efficient information transmission. The similarities between SONET and SDH facilitate seamless interoperability, allowing data to be transmitted byte by byte, row by row, ensuring efficient and reliable communication networks at various bandwidth levels. The Gigabit Ethernet Alliance introduced 10 gigabit Ethernet variants, LAN PHY and WAN PHY. The LAN PHY operates at 103125 gigabits per second, while the WAN PHY matches the line rate of OC192 STM64 at 9,953,280 kilobits per second. LAN PHY utilizes 64B, 66B line coding, whereas WAN PHY encapsulates Ethernet data using a lightweight SDH SONET frame for lower-level compatibility with SDH SONET signal-carrying equipment. Notably, 10 gigabit Ethernet lacks explicit interoperability at the bit stream level with other SDH SONET systems, contrasting with WDM system transponders that support thin SONET-framed 10 gigabit Ethernet signals. SONET SDH network management involves configuring and monitoring equipment locally or remotely. Network management systems encompass software on a terminal, data transport mechanisms like TL1Q3 protocols, and dedicated data communication channels, DCCs. Functions include provisioning network elements, software upgrades, and performance management. Clock synchronization in telecommunications networks relies on various sources, such as local external timing, line-derived timing, holdover, and timing loops, to ensure accurate timing for network operations. The evolution of SONET SDH led to the development of virtual concatenation, addressing inefficiencies in traditional concatenation methods by allowing arbitrary assembly of multiplexing containers. Virtual concatenation, along with protocols like GFP and LKS, enables dynamic bandwidth adjustments in networks. As technologies advance, SONET SDH networks are gradually being phased out in favor of alternatives like OTN and wide-area Ethernet, due to stagnation in development and increased competition from more modern solutions.